Every astronaut talks about how special Earth looks from space, just like in this Earthrise photographed from the Moon during the Apollo mission. This tiny dot is Earth photographed by the Voyager probe in 1990, but the Cassini probe also photographed Earth from 1.4 million kilometers away. This thin atmosphere sustains life on Earth. The heat of the sun lifts water into clouds and sets the atmosphere in motion, often producing huge cyclones on its surface. From space, Earth looks peaceful, with civilization's noise muted by distance and the void. Astronauts experience silence, perform spacewalks, and watch the sunrise over the Indian Ocean. The International Space Station orbits the Earth in an hour and a half. From it, you can see the curvature of the Earth and the clouds on its surface. At the planet's poles, you can admire the auroras formed by the impact of the solar wind. The Earth is not isolated, it is part of the Sun's ecosystem. Beyond the atmosphere is the cosmic void, with temperatures of only a few Kelvin. Beneath the Earth, the depths are extremely hot, with temperatures ranging from hundreds to thousands of degrees Celsius. Our place of existence is a thin band, only a few tens of kilometers thick. Let's admire our planet as seen from next to the Soyuz capsule, docked at the International Space Station above Florida, and watch the sunlight glimmering across the Pacific Ocean. I say, let's admire the southern or northern aurora dancing above the Earth's night. Or the shadow of the moon seen from the International Space Station, isn't it wonderful? The Hubble telescope floats at the edge of Earth and space. In 2009, it was repaired in space when astronauts visited it on the Space Shuttle Atlantis. After Leoglinski was repaired, Hubble got new solar panels and is now functional again. That's how the journey to the moon began with the Saturn V rocket. Man set foot on his planet's satellite for the first time. He went again on the same Apollo mission. He measured, sampled, and had fun like a child. Saturn V is the rocket that made these things possible, and 5 Wernher von Braun is the man behind it. One of these eggs hatched, I once wrote on the black and frozen sky. I, an aging telescope, constantly watch the morning, the light, the distance. The white dwarf greets me for an explosion of a nova that dies while still swallowing its nearby star. It seems that in that flooded place of light, dozens of unknown planets would exist. 2 young girls on a distant satellite grieve their mother's loss. In the core, exploded stars and unknown particles are gathered from non-existence by laws and thrown together. I wish I could be there now, far away, to feel with my human skin in the cosmos before me. I can feel the warmth of the methane seas. Choosing this Earth, I feel like a wingless Tellurian, trapped and chained in a tomb. Would you have the courage to float freely in space? To stay there without a tether? To move away from the rocket to perform maneuvers with a robotic arm? If so, that's what you would see above the mountain from space. The color of the stars in the sky reveals their temperature. It's just the opposite. Why did we expect it at the faucet? Red stars are the coolest, while blue ones are the hottest. The yellowish red of a giant like Betelgeuse barely reaches 3,000 degrees Celsius. It's a cool star, while the intense blue of a star like Rigel indicates over 20,000 degrees Celsius. It's a hot star. Aldebaran is about yellow and has a temperature of 3,900 C, making it cooler. Will you remember this next time? Space shuttles were reusable vehicles developed by National Aeronautics and Space Administration, used between 1981 and 2011 for launching astronauts, satellites, and space modules. This is the Space Shuttle Challenger in orbit above the Earth, with its cargo bay doors open. The Space Shuttle Atlantis is seen above the Bahamas before a perfect docking with the International Space Station. The Space Shuttle program ended due to high costs and significant risks demonstrated by 2 fatal accidents. The nebula's red is from ionized hydrogen, and its bluish green is from ionized oxygen. The central area is a reddish emission nebula formed from hot gas ionized by young massive stars. The blue area in the lower left is a circular-shaped nebula created by the stellar winds of a nearby star. The Hourglass Nebula was created when a sun-like star expelled its outer layers in the final stages of its life. The pillars of creation are huge columns of gas and interstellar dust located 5,000 light-years away. They are dense regions of cold hydrogen where young stars are formed. The largest pillar is about 4 light years long. Light, the red and blue colors are given by the way the starlight interacts with the interstellar gas. The Cone Nebula is a cosmic pillar of gas and dust. The radiation from young hot stars erodes the nebula. Inside the bubble nebula, there is a star that generates stellar winds pushing the gas outward, creating this sphere, the same nebula photographed from the ground. The star in the center is 45 times more massive than the Sun. This is a planetary nebula. Here, a powerful star emits radiation that shapes the ionized gas around it, creating a filamentary structure, and this is a stellar nursery. Young stars sculpt the clouds of gas into spectacular shapes, and this is a planetary nebula, with 2 symmetrical lobes, created by the stellar winds of a dying star, which is shedding its envelope in a dust-rich environment. The Crab Nebula is the remains of a supernova seen from Earth in 1054. At the center lies the remnant of the exploded star, which has become a pulsar, a rapidly spinning neutron star. The expanding gases form a spectacular filamentary structure rich in energy and radiation. The Ant Nebula is a planetary nebula with 2 opposing lobes resembling the body of an ant. The Eskimo Nebula has a bright core and spectacular outer filaments formed from layers expelled by a dying star. The Lagoon Nebula contains dense gas and dust clouds where new stars form. The pinkish-red color comes from ionized hydrogen, illuminated by ultraviolet radiation emitted by massive young stars. This nebula is young. It was created by a star in the final stages of its life, which expelled its outer shell. A hot white dwarf remains at the center of the nebula, emitting intense radiation and illuminating the surrounding gas. In this young nebula, a star in the final stage of its life emits bipolar jets, which penetrate the surrounding environment and shape the interstellar gas. Merope is a nebula made of cosmic dust, which reflects the light of a young hot star, creating a diaphanous, almost ghostly glow. A huge pillar of gas and dust in the Carina Nebula rises over a distance of 3 light years, shaped by stellar winds, with massive stars forming within it. This supernova remnant, which exploded 1,000 years ago, is seen today in X-rays. Crossing it at light speed would take 35 years. The dark areas in this nebula are dense clouds of interstellar dust that block the light from the stars behind them. The explosion in a bipolar nebula happens mainly in 2 directions, because the gas ejected by the star at the center is forced to escape along the star's polar directions. Here, the resistance of the surrounding gas is lower. The Cat's Eye Nebula displays concentric layers, jets of gas, and symmetrical arcs resulting from repeated outbursts of a dying star located at the center of the structure. Nebulae are formations of gas and dust located within our galaxy, situated at about 2,700 years. In the light, we see the Cone Nebula on the left, the cluster, the Christmas tree on the right, and the Fox-Fir Nebula at the bottom right. This imposing structure, called the Pillar, is part of the Eagle Nebula and stretches over 9.5 light years, being a giant column of gas and dust where stars are born. The intense ultraviolet radiation emitted by massive stars gradually erodes the columns of gas and dust, sculpting amazing 3-dimensional shapes, similar to natural cosmic statues floating in interstellar space. This area is full of gas and dust. The increasing pressure and heat will eventually trigger nuclear fusion and the birth of new suns. Planetary nebulae form in the final stages of a medium star's life when it loses its outer layers. As it runs out of hydrogen in its core, the star expands enormously and becomes a red giant. The remaining core becomes very dense and hot. A white dwarf, it emits intense radiation, especially ultraviolet, ionizes the expelled gas, and it begins to glow, forming the visible nebula. This is how the Ring Nebula forms, a cosmic donut with a complex internal structure. In the center of the ring, we see the hot white dwarf, the remnant of the red giant that expelled its layers and now illuminates the recently ejected layers with ultraviolet radiation. Star clusters are groups of closely packed stars bound together by gravity. They are split into two types, open clusters and globular clusters. Open clusters have hundreds to thousands of young stars. They are typically found in the galactic plane and have short lifespans. In contrast, globular clusters are dense, old, and contain hundreds of thousands. Am I the only one who thinks there are more stars here than I'd expect? Grains of sand in my hand. They're not tadpoles. Cometary knots are dense structures of gas preformed in the outer layers of some planetary nebulae. This is the tip of a pillar in the Carina Nebula, a column of glowing light, eroded by the radiation from massive stars at the top. Its interior is a stellar incubator. The Tarantula Nebula is a stellar nursery full of massive stars, stellar explosions, ionized gas, and turbulent filaments. No, it's not a girl on a swing, it's a planetary nebula. At the center, a star exploded and scattered its outer layers like Babadokia when it overheated. The star's remnant is visible at the center. We live in an internet-driven world, but our view of it differs from before. The inhabitants of this planet, when I want to travel virtually and I'm curious about how the world looks from those countries, I use a VPN. Surfshark is a VPN that gives you access to over 3,000 servers in 100 countries all over the world map. Surfshark hides your IP address to protect your online privacy. You can search for plane tickets, hotel rooms, and rental cars at lower prices. This comes with a minimalist and user-friendly app design. Surfshark Alert gives you real-time protection and alerts. And Surfshark Antivirus helps you keep your device virus-free, do a quick or full device scan, benefit from real-time protection, and schedule scans. Go to surfshark.com/Presure or use the code Presure at checkout to get 4 extra months of Surfshark VPN. The James Webb Telescope has departed Earth and entered space. There it photographed a system made up of 2 jets of supersonic gas ejected by a young star, jets that violently hit the surrounding gas. Then it captured Neptune in unprecedented detail, revealing its fine translucent rings that were previously invisible from Earth. Finally, in the infrared spectrum, it observed the Sombrero Galaxy, famous for the dense band of dust that envelops and hides the light of the galactic core. The James Webb Telescope observed the planet Jupiter in infrared, revealing spectacular polar auroras, fine atmospheric structures, and delicate rings. It also captured a dark cloud, where young stars are born, highlighted by asymmetric jets of gas emerging from the forming core. Then, it explored the center of a galaxy cluster, discovering a supermassive black hole whose jets seem to stimulate star formation in the surrounding environment. The Cassiopeia supernova observed by James Webb generated a wave of light that reflects in the surrounding dust clouds, creating light echoes. The galaxy cluster here acts as a gravitational lens, magnifying a distant and small galaxy. This galaxy was formed as a result of the collision between a small galaxy and a massive spiral galaxy, triggering shock waves that organize the stars into rings and intense star-forming regions. What we see here is the result of a Type 1a supernova explosion, a white dwarf orbiting a normal star and consuming its material. At some point, the white dwarf explodes, releasing its outer layers into space like Babadokia. I took Eminescu by the hand and ran through all the centuries after him. I introduced him to the theory of relativity and gave him a lecture on quantum mechanics. I gladly introduced him to vacuum energy and the Higgs boson, which he hadn't heard of. Eminescu diligently took notes on everything I said and then asked me if, after all this, I knew who I was. Confused, I didn't know how to answer, and he, disappointed, returned to non-existence. What else did I photograph? The James Webb Telescope, mainly in infrared. A collision between 2 galaxies whose gravitational forces trigger massive waves of star formation. An object shaped like a question mark, possibly the result of a galactic collision or a distant galaxy. The SACRAB Nebula with dust, structures, and synchrotron emission. Its filaments trace the magnetic field lines created by the neutron star's pulsation at the center. The Webb telescope in infrared reveals dust, gas, and hidden structures in the galaxy, while Hubble in ultraviolet captures young, hot stars in the initial phase of their formation. Stefan's quintet shows intense galactic interactions, collisions, massive shock waves, and compressed gas clouds, clearly visible in infrared. This spiral galaxy has an active supermassive black hole. Around it, dense dust and gas accumulate, creating regions suitable for star formation. Here is one of the most distant galaxies, located over 13 billion light-years away, offering a rare glimpse into the young universe. Just 500 million years after the Big Bang, the galaxies here, photographed by the James Webb Telescope, are billions of light-years away from Earth. That means the light left them when Earth hadn't even formed yet. The yellowish galaxies are farther away and we see them when they were older, the whitish ones are closer and we see them when they were younger. The galaxy cluster's mass bends space-time, causing gravitational lensing that magnifies and distorts galaxy images from our view. You see how they are all yellowish. The light from some galaxies has traveled over 13 billion years to reach us. Due to the expansion of the universe, this light has become reddish. We see the galaxies as they looked a few 100 million years after the Big Bang. This telescope with golden mirrors has reached space, where it orbits in sync with the Earth around the Sun. From here, the James Telescope photographed the pillars of creation, a star nursery filled with cosmic dust and gas. And this galaxy, located 38 billion light-years away, has an intense central ring of star formation and wide spiral arms rich in dust, gas, and young stars. With its infrared sensor, it looked through the dense clouds of this galaxy toward its core, where a supermassive black hole is hiding. The same infrared detector made it possible to see inside the cloud of this nebula the remnant of a supernova that exploded about 340 years ago, exploded in our galaxy. The James Webb Telescope's mirrors are gold-plated to effectively reflect infrared light. In infrared, Uranus's rings are clearly visible, and the planet appears in shades of blue and violet. Saturn looks dark at its center because its methane-rich cold atmosphere absorbs certain wavelengths. Thus, shining strongly in infrared, the rings glow intensely in infrared, reflecting sunlight. Jupiter's bands are artificially colored here to highlight the altitudes. Lower clouds appear green and blue, while higher frozen clouds are white and pink. The James Webb Telescope reveals incredible cosmic sights. It captures this binary star system, where the interaction between stellar winds forms concentric rings of dust every 8 years, visible in infrared as waves. Or this image of the most distant galaxies, whose images are distorted by the curvature of space. An extreme example is the Maltra star, an extremely distant star, magnified about 4,000 times by the gravitational lensing effect. Thank you for watching the video until the end, and thanks to Surfshark for sponsoring it. Access Surfshark/Pressura or use the code Pressura at checkout to get 4 extra months of Surfshark VPN. If you haven't subscribed, you can do it right now by pressing this subscribe button. I'm Christian Pressura from Physics Explained, wishing you all the best. Goodbye.